The first problem, take the indefinite integral of secant 3x tangent 3x dx. So for this, we let our u be 3x, then du dx equals 3. Then dx is du over 3. So let's substitute using these two. Then we get secant of u tangent of u dx is d over 3. Since it's a constant, we can take it out in front of the integral sign, put it 1 over 3. Like this. And here, we know that derivative of secant is secant x tangent x. So therefore, our final answer is secant u plus c, because derivative of secant u will be secant u tangent u. Okay, and actually for the final answer, we have to plug what u is, which is this right here. So it's 3x plus c. So this is our final answer. We can always check our answer by taking derivative of this. Then we should get this inside right here. So let's look at number 2, problem 2. Take indefinite integral of cosine of 2 over x to the 5th, the entire thing over x to the 6th dx. So for here, u is x to the 6th power. Du dx is, using the power rule, we have 6 times x to the 5th power. Let's solve for dx. So here, actually, if we plug this in, okay, so let's see that it will not work out, okay? So we'll see what will happen. X to the 6th u dx is du over 6x to the 5th. So there's nothing we can do to simplify this one right here, this one and this. We cannot just cancel these out because this argument is inside of cosine. So that means this u did not work out. So we have to do something else. We have to try different u. Okay. So let's pick u equals 2x to the 5th power, which is same thing as 2 times x to the negative 5th power. Then du dx equals negative 10 x to the negative 6th power. By the power, we have to subtract 1 from here, which is negative 6. So then du dx equals negative 10 over x to 6. And we can solve for dx here. Dx will be x to the 6th power times du over negative 10. So then using this one and this u right here, we can substitute. So let me bring it right here. I have cosine of u over x to the 6th. Remember, dx is this right here. So x to the 6th du over negative 10. And now we'll see that this dx cancels out. So we have negative 1 over 10 in front of the integral sign. Cosine u du. Now we have to think about derivative of what function gives us cosine. That is sine. So our final answer will include sine, negative 1 over 10, sine u plus c, right? We should not forget plus c. And now put back what u is in terms of x. So our final answer is this right here. Okay. So let's look at problem 3. So problem 3 is taking definite integral. And we know that by having lower and upper bound number. That means we're finding the area, the exact area between 0 and 1. Okay. So in this case, u substitution again is 4, u equals 4x to the second plus 3. Du dx equals 8x. Let's solve for dx, which is du over 8x. So using these two, we can substitute again. We have x e u du over 8x. So we'll see that this x will cancel out, right? So then we have 1 over 8 e to the u du. But now what do we do the bounds? Like, we haven't put anything here yet. We cannot just put 0 and 1 here because now everything is in terms of u. So what we have to do is that we also have to find what u is in terms of 0 and 1. So when x is 0, what is u value? Plug 0 right here. So 4 times 0 squared plus 3 gives me 3. So now 3 is the new lower bound. Okay. Then for new upper bound, we plug 1 in for x. And we get 4 times 1 squared plus 3, which we get 7. So now 7 is the new upper bound. So let me write that here again. 7 and 3. Okay. So now using fundamental theorem calculus, we can evaluate this. 1/8 e antiderivative of e to the u is just e to the u, right? So e to the u evaluated, let me actually write this again. 1/8 e to the u evaluate 7 and subtract and evaluate 3, which we can write to 1/8 e to the 7 minus e to the 3. Okay. So this is a final answer. With a calculator, yeah, we could find exact decimal. This is one way to express the final answer. So remember, for a definite integral u substitution, you have to change the bounds as we did here. Okay. So let's look at problem 4. Indefinite integral of x over square root of 1 minus 4x squared. So for here, let's try u equals 1 minus 4x squared. And du dx equals negative 8x. Then dx equals du over negative 8x. So using these two, let's substitute. We'll get x over square root of u. Dx was du over negative 8x. And you see that this x cancels out. And we can bring that negative 8 to the front, which is actually 1 over negative 8. So negative 1 over 8 square root of u du. And square root of u, we can rewrite it as u to the half power du. So then we take the antiderivative using reverse power rule, add 1 and divide by this number, which is same thing as multiplying by the reciprocal. And of course, don't forget plus c. So our final answer is this number right here. We can simplify negative 1 over, this is 2 over 24. So we can simplify to 1 over 12. U, instead of u, we have to plug what x is from right here. 3 over 2 power plus c. So this is our final answer. Okay. So problem 5, take indefinite integral of 1 over square root of 1 minus 4x squared dx. So this one looks very similar to this one. But one difference is that unlike number 4, we have just a number here. Whereas in problem 4, we had an x variable, right? So what about this problem will be different? Let's see. So for this one, we actually have to use the idea of inverse trig. Okay. So we have to know that antiderivative of 1 over square root of 1 minus x squared dx equals sine inverse of x plus c. So we have to use this fact for this problem. Okay. But in order to use this fact, this has to be an argument square. So before we take the antiderivative, we have to do little simplification, or rewrite it rather than simplifying. So 1 minus, the way I'm going to write it here, is 2x squared dx. So here we have an argument square, like we have in generic antiderivative, which gives us sine inverse. Okay. So this allows to do u substitution. So in this case, let u be 2x, then du dx equals 2, dx equals du over 2. So let's plug those in here. Let me put this. Then we have 1 over integration square root of 1 minus u squared dx was du over 2, which we get half. We can bring this half into front. 1 over square root of 1 minus u squared du. Now, so this portion right here is sine inverse u plus c. Okay, so final answer, let me write in red, half times sine inverse of u plus c. And of course, instead of u, we have to plug in what u is in terms of x. So sine inverse 2x plus c. So this is our final answer. Okay. So here we have to remember this one fact, the derivative of sine inverse. What's the derivative of sine inverse? It is 1 over square root of 1 minus the argument square. And of course, if argument is not x, we have to multiply by the derivative of the argument when we take the derivative of sine inverse. Okay, so always keep in mind of inverse trig functions when you do these problems as well. Okay, so let's look at the next one. Problem 6. Indefinite integral of 3 over 5x plus 4 dx. Okay. So here u be 5x plus 4, and du dx equals 5, and dx equals du over 5. Right. So if we substitute using these, we get 3 over u du over 5. So then this 3 and 5 right here, we can place it in front of the integral sign. So we have 3 over 5 integral 1 over u du. Now for here 1 over u, we have to remember what's the derivative of what function gives us 1 over u. It is natural log. So we have 3 over 5 natural log absolute value of u plus c. Then finally, before we conclude to a final answer, we have to plug what u is in terms of x. 5x plus 4 plus c. So this is our final answer.